Hello coders, I welcome you all. In this video, we are going to build a recommendation system, also known as recommendation engine. Recommender systems are one of the most successful and widespread applications of machine learning technologies in business. Now, what is a recommendation system? Recommendation system is a computer program or algorithm that suggests items or content to users based on their preferences, behavior, or past interactions. The main goal of a recommendation system is to help users discover products, services, or information that they are likely to be interested in. Let's discuss common types of recommendation systems. Let me try to explain our traditional offline store with a recommendation system. As you can see, the front view of the cloth store. There are many items in the store. Why are only these items hanging on the front door? Even new users can see these items without entering this store, right? We know that these items are the most popular or trending items. This is nothing but our first type of recommendation system, a popularity-based recommendation system that you might have seen on Amazon or Flipkart. If you are a new user, they are showing popular or trending items to you. That doesn't take individual user preferences into account, but recommends items that they are currently popular or widely liked by other users. This approach can be especially useful for new users who have no previous interaction history, as it offers a starting point based on what's generally popular. This is called as popularity-based recommendation system that we are going to build first in this project. Now, let's assume that you are a regular user of this clothing store. So where is the recommendation system? You can see the lady who is showing clothes to you. She is a recommendation system. You tell her, show me some good clothes. And she comes with the clothes, saying, yesterday your friends came and they purchased these items. They also liked this the most. So let me show you this first. You may like them. Here you can see collaboration in action. This method recommends items based on the preferences and behaviors of similar users. If user A likes certain items, user B is similar to user A. Then the system will recommend the items liked by user A to user B. This is nothing but our next type of recommendation system, collaborative filtering based recommendation system. Here I have used the word friends just for teaching learning purpose. This recommendation system is based on likely minded people, finds users similar to you, recommends stuff they bought, viewed, rated that you haven't yet. This is our next type of recommendation system, collaborative filtering based recommendation system. Now next, again I am assuming that you are a regular user of this clothing store. As you know, this lady is our recommendation system. Since you are a regular user of this clothing store, she knows you well. That means she knows your past behavior, your choices, price range, and other attributes. So her recommendation is based on your past history. This is nothing but our next type of recommendation system, the content-based recommendation system, where there is no collaboration and her recommendations are based on your attributes and past history. This is our next type of recommendation system, the content-based recommendation system that we are going to build in our project next, after popularity-based recommendation system. Now once again, I am assuming that you are a regular user of this clothing store. As you know, this lady is our recommendation system. This lady may combine the previous two approaches. She tells you about your friends' choices and also shows clothes based on your past behavior and attributes. So this is our next type of recommendation system, a hybrid recommendation system. In this type of recommendation system, we can combine any of our previous recommendation systems to make hybrid recommendation system. So let's begin. So in this video, we are going to build course recommendation system. For Udemy, we are going to use real-world dataset available on Kaggle. You can download this dataset from Kaggle or from my GitHub account. Link is given in the description of this video. So let's get started. So let's first import the libraries that we require. We will import others when they are needed. So let me first import pandas as PD. Let me import warnings. Let me execute this cell. As you can see, our libraries are successfully imported. Now let me write warnings dot filter warnings, and here let me pass ignore. This code disables warning in Python. Let me execute this cell. Now let's load our dataset as pandas data frame. So let me write pd dot read underscore csv, because our dataset is available in .csv file format with name udemy underscore courses.csv. Let me assign it to one variable. Data is equal to this statement. Let me execute this cell. As you can see here, now our dataset is successfully loaded as pandas data frame. Let me display top 5 rows of this dataset. As you can see over here. As you can see here, these many features are provided in our data set. Let me display only first row. As you can see here, course ID. This field contains unique identifier for each course on Udemy. Next, course title. This field contains the title of each course. Next, URL. This field contains the URL or web link to the course page on Udemy website. Is underscore paid. This field indicates whether the course is a paid or free course. It contains two values, true and false. True means paid course. False means free course. Next, price. If the course is paid, the field will contain the price of the course. Next, number underscore subscribers. This field provides the number of users who have subscribed to this course. Next, number underscore reviews. It indicates the number of reviews that the course has received from the user. Next, number underscore lectures. This field specifies the number of lectures within the course. Next, level. This field categorizes the course into different levels like all levels, beginner, etc. Next, content underscore duration. This field represents the total duration of the course content. Next, published underscore time stamp. This field provides the date and time when the course was published. Next, subject. This field categorizes the courses by its subject like business finance that you can see over here, musical instruments, graphic design, etc. So our dataset contains this many features. Now next. Now let's find shape of our dataset, means number of rows and number of columns available in our data set. So for that, let me write data, which is pointing to our data frame, and we have to use shape attribute of pandas data frame. As you can see here, total we are having this many rows and this many columns available in our data set. Now let's check for null values in the data set. So for that, let me write data, and we have to use isNull method of pandas data frame. Let me execute this cell. As you can see here, output is pandas data frame with boolean values. Let me perform sum of true values. As you can see here, output is all zeros. It means there are no any missing values in the data set that you can see over here. Now next. Now let's check for duplicated values. So for that, let me write data dot, we have to use duplicated method of pandas data frame dot any. Let me execute this cell. As you can see here, output is true, indicates that there are duplicated rows present in our data set. Now let me display duplicated rows. So for that, we have to pass this into our pandas data frame. Let me execute this cell. As you can see here, these many rows are duplicated in our data set. So now let's drop this duplicated rows. So for that, we have to write data, and we have to use drop underscore duplicates method of pandas data frame. And to modify our existing data frame, let me assign back. Let me execute this cell. Again, let me check. Let me copy this and let me paste it over here. As you can see here, output is false. Means we have successfully dropped duplicated rows from our data set that you can see over here. Now next. So let's first build popularity based recommendation system. Then we will build content based recommendation system. So now let's first revise popularity based recommendation system. As we discussed, why are only these items hanging on the front door? Because these items are the most popular or trending items. The same is true for online store like Amazon and Flipkart as well. They show the most popular or trending items to the user. As we discussed, this approach doesn't take the individual user preferences into account, but recommend items that are currently popular or widely liked by other users. So this approach can be especially useful for new users who have no previous interaction history, as it offers a starting point based on what's generally popular. So let's first build popularity based recommendation system. So let's jump to Jupyter notebook. So let me first write heading popularity based recommendation system. So let's create function to build a popularity based recommendation system. So def pop underscore rem. You can use any other name as well. Now first we have to calculate the popularity score for each course. There are many ways to calculate this score. We are going to use a very simple method. Let me first display column names. Now let's calculate popularity score for each course. To calculate popularity score for each course, I am going to use number of subscribers plus number of reviews, and I am giving 60% weightage to number of subscribers and 40% weightage to number of reviews. Now let me create new column with name pop underscore score, which contains this popularity score that we have calculated using number of subscribers and number of reviews. So in our created popularity based recommendation system, the popularity score for each course is calculated using this formula. You can see this formula combines two factors to determine the popularity score, the number of subscribers and the number of reviews. You can see we have given more weight 60% to the number of subscribers and 40% weight to the number of reviews. Here we are assuming that the higher number of subscribers indicates greater popularity. You may form different equation as well. As I said, there are many ways to calculate this popularity score. Now let me execute this cell. Also here we have to pass our data frame. Let me execute this cell once again. Let me call this function with our data frame. Let me execute this cell. Let me check first row of our data frame. As you can see here, we have successfully created this column which contains popularity score that we have calculated using this equation. Now next, now we have to sort our data frame into descending order based on popularity score. This one means that the courses with the higher popularity score will be at the top of the sorted data frame. Let me show you this. So let me write data which is pointing to our data frame, and I'm going to use sort underscore values function, and we want to sort our data frame by popularity score, and let me set ascending to false because we want result in descending order. And let's create new data frame with name df underscore sorted is equal to this statement, and let's return this data frame. Let me execute this cell and let me execute this cell as well. As you can see over here, let me check. As you can see here, now our data frame is sorted based on this popularity score, highest to lowest, that you can see over here. But in place of returning entire data frame, let's just return this course title and popularity score that just we have calculated. Let me execute this cell and let me execute this cell as well, as you can see over here. But we are interested in top 5. So let me use this head method of pandas data frame. Let me execute this cell and let me execute this cell as well, as you can see over here. Top 5 courses based on popularity score that you can see over here. So this way we can build popularity based recommendation system which recommend items that are currently popular or widely liked by other users that you can see over here. As we discussed, this approach can be especially useful for a new users who have no previous interaction history, as it offers a starting point based on what's generally popular that you can see over here. We have successfully built our first recommendation system, popularity based recommendation system that you can see over here. Now next, now we are going to build content based recommendation system. Let me add heading content based recommendation system. So now let's revise content based recommendation system. So as we discussed, we assumed that you are a regular user of this clothing store. Our recommendation system knows you well. That means she knows your past behavior, your choices, price range and other attributes. So here her recommendation is based on your past history. And this is our content based recommendation system where there is no collaboration. Her recommendations are based on your attributes, and past history. So let's build content-based recommendation system. So let's jump to Jupyter Notebook. So let me display first row of our data frame. So first, here we are going to build content-based recommendation system based on this course title. Then we will check the performance, means recommendation. If required, we will use other feature to build content-based recommendation system. But first, we are going to use only this feature or this column, course title. As I said, if we required, we will use next column as well. So let's first clean our text, means our course titles, by removing stop words and special characters. So for that, let me import neattext.functions as nfx. So let's first display course titles. As you can see here, our course title contains special characters. You can see here. Also different stop words that you can see over here. So we are going to remove these stop words and special characters from this course titles. So first, what are stop words? Stop words are the most frequently used words in a language such as articles, prepositions, conjunctions, etc. These words don't contribute much meaningful information to the text. Examples of English stop words are the, a, and, so, what, etc. So why to remove stop words? Stop words are removed to eliminate low-level information from text, allowing more focus on important content. In other words, we can say that the removal of such words does not show any negative impact on the model we train for our task. Removal of stop words reduces the dataset size as well, and thus reduces the training time due to the fewer number of tokens involved in the training, right? Please remember, stop words are not always removed. The decision to remove them depends on the task and goal. Please do remember this. For example, in the sentiment analysis, stop words may not be removed. Removing them can alter meaning of a sentence. For example, here is the one course review. The course was not good at all. Suppose here is the one course review. Now you are removing stop words. So after removing stop words, the review looks like this. Course good. We can clearly see that the review of the course was negative, right? However, after removal of stop words, the review becomes positive. You can see here. So the removal of stop words can be problematic here. But here we are not performing sentiment analysis. So we can remove stop words. So let's first remove stop words from course titles. This one. So let me use function apply and nfx dot remove underscore stop words. To modify our existing data frame, let me assign back. Let me execute this cell. Let me check. As you can see here, and other stop words are removed that you can see over here. Now let's remove these special characters. So let me copy this statement. Let me paste it over here, and here let me write nfx dot remove underscore special characters. Let me execute this cell. Please look at here and this. Let me execute this cell once again. As you can see here. So we can say we have successfully removed stop words and special characters from course title. Since our course title are somewhat clean. So now we can build our content-based recommendation system using this course title. So first, we are going to convert these course titles into vectors using count vectorizer. In simple, we can say that the count vectorizer converts text into a numerical format. In the second step, we will find similarity between these vectors to recommend the courses. So let me explain you vectors in 2D like this, X and Y. So as I said, we are going to convert these course titles into vectors. So if user selects this course, we can recommend closest vectors. These vectors means similar courses to the users. So let's first import count vectorizer from sklearn. So from sklearn dot feature underscore extraction dot text, let me import count vectorizer. Let me execute this cell. Let's create instance of count vectorizer with CV is equal to count vectorizer, and let me set max underscore features to 3000, and let me write CV dot fit underscore transform data and course underscore title, and let me assign it to one variable with name vectors is equal to this statement. Let me execute this cell. Let me check. As you can see here, count vectorizer returns sparse matrix. Visualize. Let me convert it into numpy array. Let me execute this cell and let me execute this cell once again. As you can see here, we have successfully converted our course titles into vectors that you can see over here. Here we have set max underscore features to 3000. So count vectorizer will only include top 3000 most frequent words in our corpus. Corpus means collection of all course titles. So here count vectorizer combines all the course titles and make one large text which is called as corpus. And here you can see we are including top 3000 most frequent words in our corpus. You are wondering why 3000? It is just try and error. You can try with 2500, 3000, 3500, 4000, 5000, 10,000, any. As I said, this is just try and error based on the performance of your system. But lower is better because small matrix is easy to process. Lower is better. Otherwise, this is just try and error. So we have successfully converted our course title into vectors. Let's discuss count vectorizer first. Then we will find similarity between these vectors. To find closest vector means closest courses that we can recommend to the users. But let's first discuss count vectorizer. So as I said, a count vectorizer is a text processing tool used to convert a collection of text documents into a numerical format. This is one of the most basic and simple methods to convert a list of words into vectors. Using a count vectorizer, we can represent these courses as a metric. Each row in the table represents a specific course title. Here you can see course A, course B, course C, and you can see course title. Learn Python programming for beginners. Advanced Python programming and analysis. Introduction to data science with Python. You can see here each row in the table represents a specific course title. In this example, we have taken only 3 courses A, B and C. This one. But you can see our dataset contains these many courses. 3672 courses that you can see over here. And here you can see each column corresponds to a unique word found in the entire collection of our course titles. This is our corpus. You can see in our recommendation system, we have selected 3000 most frequent occurring words that you can see over here. So the words are extracted from the entire set of course titles. Here we have used only 3 and are listed as column headers from the entire set of course titles. Here we have used only 3 courses. Now here you can see values. So the values in the table represents the frequency of each word in each course titles. Here you can see values 1, 1, 1, 0, 0. Let me take this value. So here you can see 1 means Python appears once in the course title of course A. This one. Here 0 means this particular word learn not appears in the course title of course B. That you can see over here. Learn is not there. So here is 0. Here is 1. Means the Python word appears once in the title of course B. Likewise. So this is our first vector. This is our second vector. And this is our third vector. So this way count vectorizer converts our documents into vectors that you can see over here. So let's jump to Jupyter Notebook. As you can see, our vectors are ready. I forget to tell you one thing. We can also check these 3000 top frequent occurring words. Let me show you this. So cv.get underscore feature underscore names. As you can see here, our selected 3000 top most frequent occurring words that you can see over here. Let me find length of this list. As you can see here, 3000. Also you can check shape of our vectors. As you can see here, number of courses and our selected 3000 most frequent occurring words that you can see over here. This is the size of our matrix that you can see over here. So now our vectors are ready. We need to calculate the similarity between vectors, specifically the similarity of the first course with the rest of the courses and similarity for the second course with the rest of the courses. Likewise, let's first discuss cosine similarity. Cosine similarity is a metric used to measure the similarity between two vectors in a multi-dimensional space. Cosine similarity measures the similarity between two vectors by calculating the cosine of the angle between the two vectors. As you can see here, the cosine similarity between two vectors A and B is calculated as follows. As you can see here, cosine similarity between two vectors A and B. Here A dot B is the dot product of the vector A and B. Here norm of A and norm of B are the magnitudes or the length of vectors A and B. So let's calculate the cosine similarity between course A and course B using the count vectorizer metric. This one, our first vector for course A, and this is our second vector, course B. So here we are going to calculate the cosine similarity between these courses, course A and course B. You can see here A into B, this one, A into B, 1 into 0, 1 into 1, 1 into 1, 1 into 0. Likewise, that you can see over here. Here you can see square root and square. 1 square, square root of this vector. It's square of each and every elements. 1 square plus 1 square plus 1 square plus 1 square plus 0 square. Likewise, you can see here 1 square plus 1 square plus 1 square. Likewise. Now here again, square root of this vector and square of each element. 0 square plus 1 square plus 1 square plus 0 square. Likewise, you can see 0 square, 1 square, 1 square, 0 square, 1 square. Likewise, and as you can see, the cosine similarity between course A and course B, this one, is approximately 0.33, indicating some similarity in their titles. The cosine similarity values between -1 and +1. The cosine similarity of 1 implies that the two documents are exactly same. The cosine similarity of 0 could conclude that there are no similarities between the two documents. In our case, course titles, indicating some similarity in their titles that you can see over here. So in our course recommendation system, we are going to calculate cosine similarity between all course pair and recommend courses with the highest cosine similarity to ones a user has shown interest, as they are luckily to be more similar in content. Now let's jump to Jupyter Notebook back. So let's import from sklearn.matrix.pairwise. Let me import cosine similarity and cosine similarity, and here we have to pass our vectors, and let me assign it to one variable, similarity. You can use any other name as well. Let me execute this cell. Let me check. As you can see over here, similarity score. You can see here, this is first course title. Similarity with itself, 1. Similarity of first course title with second course, third course. Likewise, now this is second course title. Similarity of first course title with second course title. Similarity with itself. Similarity of second course title with third course title. Likewise, for all the courses that you can see over here. Let's check shape of this matrix. As you can see over here, 3672 cross 3672, right? Similarities with each other that you can see over here. So now let's pass the index of the first course to this similarity measure. So let me write similarity, and here first course that you can see over here. Similarity of first course title with rest of the course titles. Here similarity with itself. So first you can see here we have to pass course index to this similarity measure, right? And we have to sort this in descending order, means higher to lower. So for that, let me use sorted. Let me copy this. Let me paste it over here. Let me execute this cell. As you can see here, similarity score of our first course title sorted in ascending order, but we want in reverse. So let me set reverse to true. Let me execute this cell. As you can see here, highest similarity score with first course title, second highest similarity score with first course title, And as I said, similarity with itself. So first remember, in similarity measure, we have to pass course index and we have to sorted this in descending order because our goal is to identify the top 5 similarities. That's why here we have sorted the similarity scores in descending order, higher to lower. So a challenge we encounter during sorting is that we lose the index information that you can see over here, which is essential to identify the corresponding courses. To address this issue, we have to use enumerate function. Here, enumerate. Let me execute this cell. As you can see over here, but you can see sorting is performed on the index by default that you can see over here, but we want sorting based on the similarity score here. So here we have to use one parameter of the sorted method key, and also we have to use lambda function x and perform sorting based on the first index, this one 0 and 1. So 1. Let me execute this cell. As you can see here, course title index with similarity score with the first course title that you can see over here. We can display top 5 or top 10. Let me display top 5 that you can see over here. But here it is showing index, but we are interested in course title. So here we have to convert these indexes to course title. So we have to map these indexes with course title. So let me write data. Let me use iloc method and let me pass this 39. Let me execute this cell and we are interested in course title only that you can see over here. So let's combine this all into one function. Let me create one function, content recommendation system. You can use any other name as well. As you know, first we have to find index of the course entered by the user. So here course underscore title, user enter particular course. So we have to fetch index of the course entered by the user. Let me assign it to one variable, course underscore index is equal to this statement. Let me take this course. Let me execute this cell. Let me check, as you can see over here. So let me copy this statement. Let me paste it over here. In place of this specific course title will be entered by the user. Now we have course index that we have to pass in the similarity measure, this one. Let me copy this. Let me paste it over here. In place of this specific course 1, here we have to pass course underscore index. Index of the course title which is entered by the user here. And let me assign it to one variable. SIM is equal to this statement. You can use any other name as well. Now next, this one, we have to sort this in descending order. Let me copy, let me paste it over here. Let me copy this. In place of this, here we have to pass this. Let me assign it to one variable. Course underscore list is equal to this statement. Now we have to map these indexes to course title. So let me copy, let me paste it over here, and here we have to use for loop. So for I in course underscore list, and here just we have to replace this specific index to I0. Let me execute this cell. Let me call this function content underscore recommendation with some course title. Let me take this first one. Let me copy this course name. Let me paste it over here. Let me execute this cell. Sorry, here we have to write print. Let me execute this cell and let me execute this cell as well. As you can see here, our recommendation based on the content that you can see over here. So user selected this course. So recommendation is based on this content that you can see over here. So as you can see, this is our content based recommendation system. Recommendations are based on attributes and past history that you can see over here based on the content. So this is our content based recommendation system that you can see over here. But can you see some problem? You can see over here. This course is recommended to the user, but user has selected this course, which is banking course. But our recommendation system recommends this course as well and this course as well that you can see over here. From this we can say that still we have to improve our recommendation system. So let's try to improve our recommendation system. So in place of this course title, let's use other feature as well to build our recommendation system. So let's use this feature subject with course title, and let me create one new column in our data frame with title and subject. You can use any other name as well. Let me execute this cell. Let me check. as you can see over here. So here in place of this into count vectorizer, now we have to use this, which is combination of course title plus subject, this one. So let me execute this cell as well, and this cell as well. So we have successfully created vectors using this course title and subject. Let me execute this cell, this as well, this. Now let's find cosine similarity, this, and this as well. Let me execute this cell. Let me execute our created function and this as well. As you can see here, now our recommendation system is improved, that you can see over here. Now it recommends proper courses, that you can see over here, as per the user content, that you can see over here. So this way we can build popularity based recommendation system and content based recommendation system, that you can see over here. As you can see here, I have created GUI for our project course recommendation system, that you can see over here, using tkinter, exactly same way as we have created for our previous projects, that you can see over here. This function is for popularity based recommendation system, and this is our next function for content based recommendation system, that you can see over here. Let me execute this cell. As you can see here, GUI for our course recommendation system, and here you can see, here we are showing most popular or trending courses to the new users, that you can see over here, using our popularity based recommendation system. You can see here popularity score as well. Now assume that user selected this particular course. So now we assume that user is a regular user. So we can recommend courses using content, means using our content based recommendation system. Let me press this button. As you can see here, now we recommend courses to this particular user based on content, using our content based recommendation system, that you can see over here. So this way we can build popularity based and content based recommendation system, that you can see over here. Hope you like this video. Please don't forget to subscribe this channel. If you like this video, smash that like button. Thank you very much for watching this video. Take care. Bye bye. See you in the next video.